Hey guys, today we are going to be going over DNA replication in prokaryotes, and I just wanted to point out real quick that prokaryotic DNA, typically found in like bacteria for example, is circular. It's a circular plasmid of DNA as opposed to chromosomes, and these ladder bonds that aren't actually the rungs but along the side that kind of hold it up are referred to as phosphodiester bonds. And when we're looking closely at replication, the plasmid DNA has to find a spot to start unzipping, known as the origin. And as you can see here, there's a directionality to how it's being built, the direction, and that direction is being built in the 5, 2, 3 direction. The way we can know this is we see this is our template right here, our 5, so we can imagine that there's a 3 here. On this side, it's going to be a 5. So we're building in the 5, 2, 3 direction, and we're going to see how that translates over to here. So basically what we have is we have helicase, which is the enzyme that's unzipping the actual DNA. We have single-stranded binding proteins, which keep the DNA unwound while it's being replicated. We have primase, which lays down the primers so that our big DNA polymerase enzyme can actually make the new DNA that's being replicated nucleotide by nucleotide by finding a primer and building in that direction. Notice that this is the template strand being built in the 5 to 3 direction, and it will be continuous. It won't have any stops. Whereas the lagging strand right here is being built in the opposite direction because it has to follow that 5 to 3 directionality. And as you can see here, that requires multiple primers to come in, and basically every so often a new primer will be, thanks to primase, will be placed, and then the DNA polymerase will come in and make a small section of DNA, and then it will stop. And these fragments aren't complete. They're referred to as Ozaki fragments, and imagine a little space in between this fragment that just got made and the replicated DNA over here. Ligase is the enzyme that's going to connect the Ozaki fragments and basically make a complete strand of DNA both on the lagging strand as compared to the leading strand. And last but not least, we have an enzyme called gyrase. And what gyrase does is prevents supercoiling, which is an issue with the actual template, like the actual DNA itself, from twisting itself up so tightly or loosely that it will start having hiccups in the system and not replicate your DNA correctly. Okay, thank you. Bye.